we start with the acid, base and buffers. So what is the acids, base and buffer? Before the essence years, so we find that no particular definitions are given for the acid base, now characterize the definition, but it is need to characterize the chemical compounds in particular groups, acid, base and buffers, so we can be classified and we can be used according to them. So very important in the acids and base and required. Now in recent in previously they called as acid. What is the substance? Has the sour taste and its aqueous solutions turns blue litmus to its red, so it react with the base. It is a general characteristics of acids before define any theory of the what is the acids and base. Now what is the base? Base are the substance which have the bitter taste. Okay, what is the bitter taste? And its aqueous solutions turn red litmus to the blue color. So it is a general things or general definition of the acids and base before the any can be provide. Now the different scientists have then the different research carry out and they propose different concept of regarding the acids and base. The first will can be explained by the RNS theories. Okay, then Bronsted-Lowry theory, Lewis acid base theory and hard soft acid base concept. Okay, now these are theory explain about their behavior characteristics of acid and base, so we can be understand the what is the acids, how they will be react, how they will be neutralized and how the reaction will be occurs between the acids and base, and how the pH, pK value it can be determined by the different theories. Now what is RNS theory? Okay, in before the any theory, this first theory which can be introduced by the RNS independently, that is a acid base concept was introduced by the RNS theory. Now acid, as per the RNS theory, the acid defined as any hydrogen containing substance which give the H plus ions in aqueous solutions, means which give the proton to the in aqueous solution. When any compound solution dissolve in the waters, okay, aqueous means the waters, it dissolve in waters, it will be give the H plus ions, so it is called as the acids. Now base, so how they will define the base? The base defined as any hydroxy group containing the substance or group capable of providing the OH ion, minus OH ion in aqueous solutions. So in aqueous solution they have given the OH minus group, or these ions can be given by the any compounds substance which are given, that is called as a base. So these are the two general definitions given by the RNS as per their the experimental and the organizing. So here the as per the definition of the RNS theory, so we can be called as a HCl, hydrochloric acid is a acid, and sodium hydroxide is called as a base. Now see the reactions. What is the HCl? When dissolved in the waters, they give the two ions, one H plus ion proton and one chloride ion. So here the H plus ion proton will be produced given by the HCl, so it is called as a acid as per the concept of RNS. Now NaOH, sodium hydroxide, in dissolved in water they will be give the OH ion minus, so it is called as a base. So and how the as per the RNS theories, how the neutralization reaction is carried out. Neutralization reaction involving the combination of the H plus ion or OH ion plus ion and to form water molecules. So when the acid base reaction are the carry out, the formation of the water molecules is called as neutralization reaction. We also know that the general concept, the acid base are reacted, they form the salt and water. So water is again the neutralization of the, means the what are the acid ions, that is H plus ion, and what is the basic ion is the OH ions. So both are the combined to each other, so they form the water molecule. So this is a neutralization reaction explained by the RNS theory. Now the RNS theory have their limitation. Means the limitation of RNS theory, they have the some of the concept of acid base are not be mentioned. The what is the limitation? First limitation of the RNS theory, the definition of acids base are only in terms of aqueous solution, not in terms of the substance. Means the RNS explain the compounds are acidic basic when they are dissolved in the water, when they dissolve in the aqueous solution, but not as actually in the substance in the pure form they are the acidic or basic. They are not be represent their characteristics as pure in substance, or they are there in the substance. And second limitation of the RNS theory, they also not explain the acidic basic characteristic or basic properties of the substance in non-aqueous solvent. Non-aqueous means the other than the waters, means it not be explained that it may present in the in alcoholic solvent, not be in the benzene aldehyde, also many the ammonia solution, ammonia. So these are the compounds, those so many. So one example is given is them ammonium nitrate in liquid ammonia act as a acidic, okay, but not give the H plus signs, means they not be given the H plus signs though, so it not be explained the how it is a acidic. So it is some limitation of the RNS theory. Now third limitation of the RNS theory, the neutralization of acid base in absence of solvent could not be examined. Means the neutralization reaction of acid base, when the two acids and base are the reactant, the neutralization are carried out in absence of solvent, that also not explained by the RNS, because the RNS theory explains that they have the characteristics of acid base in aqueous solution. In aqueous solution they have the combined acid base reaction is carried out and neutralization reactions occurs, and they will be produce the salt and the waters, but it is this will be explained by RNS that it is carried out in the aqueous solution, not in the pure form, so it not be able to explain. Now fourth limitation, the basic substance which do not contain the hydroxide could not be explained by this theory. Means the so many compounds are the basic characteristics, but they not have the OH ions, means not have the OH but have the characteristics. So many organic compounds, ammonia, like amines are the so all the basics, or organic amines are the basic in characters, but not having the OH ions. They not be giving the OH ion hydroxy ions to the aqueous solution. So these are, even though they have the so that their basic character, so this also not be explained by the RNS theory. It cannot be also explained the acidic characteristic of certain salt such as aluminum chloride. Here the example aluminum chloride in aqueous solution. Aluminum chloride have the acidic compound, they are strong acidity, they have given them, but these salts have not been given the H plus ion. So here also it not be explained how it is acidic. So they have the some limitation, they have the some limit period of the this RNS theories are the limited particular to the compounds containing the H plus ions, or able to give in the H plus ions, or compounds having the OH ion is giving as a OH plus ions, that are called as base. The theory will be limited up to this H plus ion and OH plus. They will not be explained the other things which are the happens. Now the second theory given by the Bronsted and Lowry, that is also theory called as a proton donor and acceptors. Means here the not a H plus donor but it's clearly mentioned in Bronsted proton donor and acceptor. It is just some different things from the your RNS theory. What is it? In 1923, the Bronsted in Conventions and Lowry in London independently they will propose this general definition of acid and base. Okay, they independently, they are not be combined, they are doing their research, but independently they are defined. So as per the Bronsted and Lowry theory, the acid compound defined as hydrogen containing material, it may be molecules, cations, ions, that is capable of giving the protons, capable of donating proton H plus ions to any other substance. Means if a compounds having the H plus ion of protons, and they have capable of providing their H plus ions to any other substance, so they are called as acids. Or the compounds, it may be molecules, ions, or cations, it may be anything that are not only the related to substance, or it also not be only in the aqueous solution. Okay, now where is the whereas as a base may be defined as a substance of molecules cations, anions that can be accept the proton from the any other substance. When the base are the compounds that can be accept the protons, and acid is a donate the protons. So it is called as a proton donor and acceptor theory. Means here in short we can be said as the acid is a compound that is donating the proton and base is accepting the proton. It is a in short definition of the defined by the Bronsted and Lowry. So some example we can be say in the acidic. So here in the example in the reaction we are written the that hydrochloric acid HCl, when they are the HCl are the react in the reaction they will be give the H plus ion plus chlorine, means the HCl is donating the H plus ions. Okay, now similar way the acetic acid, it is organic acid, so it will give the H plus ion plus acetate ion. Similar the HSO4, it also give the H plus ion plus SO4 ions, so it give the H plus ion. Like a hydronium ion, they will be H plus ion plus water molecule. In ammonium, the ammonium will be the H plus ion plus ammonia. Now some example of bases that will in base. What is the definition of the base? That can be accept the OH ions. Okay, so here the example is if OH ions, okay, it sorry in base is example they can be accept the protons, that is called as a base. Now example is OH ion that can reacted with the H plus ions to form the water molecule, so OH ion is the base. The same way will the water molecule when you accept the protons final formation of the hydronium, so water also act as a base. Acid have the water molecules have the both the characteristics, dual characteristics. It can be also donate the H plus. If you donate the H plus ion, then called as a acidic. If you accept the H plus ions, then it is called as a base characteristic. The depending upon the situations, they have to act as a acid or base. Similar the SO4 ion, so it can accept the H plus ion, so formation of HSO4. So now the ammonia can be accept the protein, can accept the protons, so called as a base. Similar with the carbonic acid, so can accept the proton, the formation of the carbonic formation of carbonium. Carbonium ion can be accept the H plus ion, when the proton can be accept the formation of the carbonic acid. Now then as per the protonation, the formation of the conjugated, one of the concept is conjugated acid base pair. Now what is the conjugated acid base pair we can be explained here. First of all you can be understand what is the reaction. Hydrochloric acid plus water molecules reacted, so reaction is a reverse and forward reaction. Okay, forward and reversible reactions, so it can form the hydronium ion plus chlorine. If reversible can be the hydronium plus chlorine, the formation reactant, they form the hydrochloric acid plus water molecule. So in this reaction hydrochloric acids donate a proton to water called as acid, means HCl is donate the H plus ions to water molecule, so it called as a acid. Okay, now water accept the protons from the HCl, so is therefore it's called as a base. Means in the reaction acid is a acid and H2O is the base, is the concept. Now water accept a proton from the HCl, is therefore in reverse reaction. Okay, so in a reverse reaction there is a hydronium ion donate a proton to a chlorine ion in a reverse reaction. Okay, hydronium ion to donate the proton to chlorine ion, and H3 plus is an acidic, and while chlorine ion is which can accept the proton from the hydronium ion, it is a base. So in a reverse reaction the hydronium ions can be donate the as H plus ion, means the proton can be donated to chlorine, so it is called as a acid, and Cl ion can be accept the protons from the chlorine, so it is called as a proton. So this is acid base pair formed from each mutually by the gain and loss of proton and called as a conjugated acid and base. Now acid 1 plus base 1 means what is the conjugated? HCl is a acid and Cl minus is base. These are the both conjugated acid and base. Like similar water and hydronium ion, these are the conjugated acid and base pair. That's why we written the acid 1 HCl and a base 1 is a chloride ion. So these HCl and chloride ion both are the conjugated acid base, and water molecule and hydronium are the acid base pair. So in the above reaction, acid is labeled as acid 1 and its conjugated base or okay. So this is called as acid base conjugated base. For some example of the again the acid base pair, like sulfuric acid plus water molecules form hydronium and plus HSO4 minus sulfur ions. Like in acetic acid plus water molecules form hydronium plus acetylene ion. Ammonium plus water molecule formation of the hydronium plus ammonia. So these are the conjugated acid base pair. We have the sulfuric acid plus HSO4 are the conjugated acid base and water and hydronium. Like either the acetic acid and acetate ion are the conjugated acid pair. Ammonium and ammonia are the conjugated acid base pair. So water having the dual characteristics because it can be accept the proton and donor. Already I have explained that proton water have the dual character. Dual characteristics means that it can also act as acid or also act as a base. So we can be see the example like water molecule plus hydrochloric acid. In this cases the HCl donate the H plus ion to water molecule, so water act as a base and hydrochloric acid is acid, so hydronium ion formation. So in this reaction, first reaction there will be formation of the they can be act as a base. Okay. In second example where the water molecule plus ammonia conversion, ammonia reacted, the ammonia can be accept the proton from the water molecule, so that water act as a base. Water act as a acid because water is donating the H plus ions to the ammonia and formation of the ammonium. So in this case the water molecules and OH ions are the conjugated acid base pair, and ammonium and ammonia is the conjugated acid base pair. What is the conjugated acid? According to definition, strong acid is one which readily donate its proton to base, so that conjugated base of such acid must be necessarily weak, and to whom we can be called as acid base. According to definition, strong acid is one of the which readily donate the protons. So which can be, those are the readily donate, those are the readily ionizable, and those are the highly ionizable, those are the highly donating the protons, that are called as a stronger acid. So their corresponding base are the weak. Okay. Then second general rules is that strong acid have a weak conjugated base and strong base have the weak conjugated acid. This is a general source which can be called who are the conjugated acid and base pair. If a strong acid conjugated acid, then always the base is a weak. If a strong base, then weak acid. Then remaining, if a weak acids, then strong base, and if a strong base, then weak acid. These are the conjugated acid base pair. Now Limitation of the Brownstein and Lowry thing. What is limited? Brownstein and Lowry concept expensive ion. Brownstein and Lowry concept lay excessive on the proton transfer. They only all the definition of the only on the proton donor and acceptor. Nothing else will be happens in the Brownstein. So although it is true, but most of acid are protonic in nature, yet there are the many which are not protonic nature. So here also those are the non-protonic in nature, they not be explained by the Brownstein-Lowry theory. Then how they will be acidic and basic, that is also one of the problems. The similar example we can do the aluminum chloride. They are not a protonic nature, they not be donating the protons. So how it is acidic? So it is one of the example where the limitation of the last number of the acid base reaction are known in which no proton transfer can be takes place. In the proton transfer will not be takes place, but even though acid basic reaction. Similar example is given the SO2 plus SO2. In this reaction formation even the acid SO2, then the exposure to some heating reaction, the reaction is takes place between the two molecules of SO2. So this thionyl oxide can be reacted, then the two reaction is formation. Then SO2 plus ions means here the 2 electrons are the lost, and here the 2 electrons are the accepted. So here the concept are the difference. So see there one loss of the oxygen here and one loss of the taking one the base. So here the exchange of molecule exchange of the oxygen and electrons, but it not be explained the Bronsted and Lowry theory. Second thing, thus the protonic definition cannot be used to explain the reaction occurring in non-protonic solvent. Also, we cannot be explain the theory which are the occurs in the non-protonic solvent like COCl2, SO2, NO2, SO4, and so many. These are the organic solvent, the non-protonic solvent. These are not to be explained by the this Bronsted-Lowry theory. These are the limitation of the Bronsted. Third theory for the Lewis as for acid-base theory, that is Lewis theory, that is also called as electron donor acceptor system. In the Lewis theories, they are the given the definition of acid base, definition of acid and base according to the electron transfer. So what is the college? According to Lewis acid, acid may be defined as any species, it may molecule, radical or ion that can accept an electron pair to form a coordinate bond, and base may be defined as any species that can be donate an electron pair to the formation of the coordinated bond. In the Lewis theory, there is the concept of the formation of the coordinate. The acid base are the defined in terms of the electrons with the formation of the coordinate bond. So in the simple way, the acid is an electron pair acceptor or base is a electron pair donor. The electron, those have the electron donor, electron pair, they have the donating the electrons to the any species, they are called as a base. So it is again the different theory than the previous way. It can be so the Bronsted theory, Bronsted-Lowry theory and Arrhenius theory. Now it is clearly about the transfer of electrons. Okay, the process of neutralization in the Lewis theory is simply defined by the formation of coordinated bond between the acid and base. So what is the neutralization process of nucleus? Only the formation of the coordinated bond between the acid and base. The simple example you can be take that protons plus react with ammonia. So in this protons, H plus ion dot is called as, that is act as acid because it accepts the lone pair of electrons from the ammonia. So ammonia having the nitrogen and nitrogen having the one lone pair of electrons. So in this case, ammonia are donating the electron pair into formation of the coordinated bond. So ammonia is called as a base. So in above reaction, so in this reaction, the ammonia proton will be accept the lone pair of electrons called as a protons, and ammonia is donating the lone pair of electrons, so called as a base. Now we take the another example, the boron trifluoride plus ammonia. So boron trifluoride, first suppose the boron in boron, their outer cell, one of the empty cell are the present, so they have the power of accepting the one lone pair of electrons. So with that, so boron can be accept the pair of electrons from the ammonia, and ammonia are donating the electron pair to the boron. The formation of the complex is a BF3NH3. So in this way, formation of complex, so BF3 accept the one lone pair of electrons from the ammonia, so it is called as acid, and the ammonia donate the one lone pair of electrons, so is therefore as a Lewis base. There are the several examples of acids, and Lewis acid and Lewis bases we can be called like, then H plus ion protons, NH4 plus, potassium plus, potassium ion, sodium ion, cupric ion, aluminum, those are the carbon ion. So generally say that those are the Lewis acid or called, those have the positive charge on there are the Lewis acid, or having the capacity to accept the, or there the unfair valence cells can be accept the electron pair called as a Lewis acid. In Lewis bases, the Lewis example of the ammonia, water molecule, OH, Cl minus, Cn minus, nitrile and the sulfur. So these are the molecules. See the examples. So in this example we can be identified that those are the negative charges are generally the Lewis bases, or the molecules having the lone pair of electrons, so act as a base. For example, the nitrogen and oxygen are generally have the lone pair, or the compounds having the these types of the atoms, so generally they act as a base. because they have the capacity to donate the electrons. Not generally it can be give the act as a base giving the electron field, not be generally. Okay, so these are the Lewis acid and Lewis bases. Now what is the limitation of this Lewis acid base concept? Means the low electron donor function. The strength, what is the strength of acid and base is found to depend on the type of reactions. Okay, means we cannot be identify the what is the strength of acids and base, what is any process we can adopt and we can be calculate then, because it purely depend on type of reaction. What type of reaction, according to we can be shy it is the this much strength of this acid. So this is the problem with the limitation. So it's not possible to arrange the this all the compounds arranged in any order of their relative strength. Means if you relative strength we can be put up and we can be called as these are the higher strong acid and weak acid as per this definition. Then Lewis acid, second limitation of the Lewis acid base concept is Lewis acid base reaction involve the electrons. What is the illusion? Involve the electrons, donation of electrons or acceptation of electrons. So it electrons involving is a very fast reactions. However, there are many Lewis acid base reactions that are the slow. So Lewis acid base in that are slow will not be explained how these are the reactions slow, even though involving of the electrons transpiration. So these are the limitation of the Lewis acids. So these are the three acid theory we can be. First, suppose the RNS theory, that is we accept the related to proton and OH, and those are the proton H plus ion and donating the OH. The acid are the H plus ion donating and OH and donating are the base. In Bronsted theory, donating the H plus ion are acid and accepting the H plus ion are the accept. But from the both the theory, these Lewis acid are the more promoting and more different from the others. They involving the clear concept of the electron transfers. Means the electron accepting molecular species called as acids, or electron donating species are called as base. Now one of the concept is hard soft acid base concept. The hard soft acid base concept can developed by the R.G. Pearsons. In generally also it called as a hard soft acid base R.J. Pearson principles. This concept does not advance any definition of the acid base, but while the retaining the Lewis concept of acid base, it provides the qualitative view of various factors involving the stability of acid base complex, involving the charges, size of the molecules, it can be involved. So this hard and soft acid base concept, it not be give the any different definition of the acid and base, but they involving the providing the quality of the acid and base. What is their quality? According to different influential factors, there may be size, there may be related to charges. These are the difference involving in this. So they have the put up this hard and soft acid base concept. They have the classifying the acid base into different different parts, like hard acids, soft acids and borderline acids. Then in similar way the base is hard base, soft base and borderline base. So in borderline, particularly in borderline acid or base, those are not fit in particularly the hard acid and soft acid. They are called the intermediate between the both the they are called as a borderline. On the border they will be, so they will not be fit in the soft acid and not be fit in the hard acid. So called electron acceptor having the high positive charge, relatively small in size, unfilled valence shell orbital, leading to high electron negativity, means electron seeking, and low polarizability, means to whom we can be called a hard acid. Generally electron accepting high positive, means their positive charges means high, means their positive density on the that radicals is high, and the atoms are then small in size. Okay, and their unfilled valence shell means the cells are generally unfilled there with the electrons. Okay, then and leading to high electron negativity. okay, leading to high electron negativity, म्हणजे electrons they asking the electrons more there, and low polar eligibility, म्हणजे their polar eligibility are the in the low in condition. The example we can be say that the H plus ion, lithium, sodium, potassium, magnesium, say aluminum, ferric, HX, the hydrogen content molecules. So these are the hard acids. Now what is the soft acids? The electron acceptor having a low positive charge, different then opposite you can be saying hard acid is a high positive charge, the soft acid is the low positive charge, relative large size, their size is small, here the size is large, okay. Filled valence cell, they are unfilled cell, here the filled valence cells orbitals, so leading to low electronegativity and high polarity, completely opposite to their. So this example you can be said that the copper ion, silver ion, gold, then mercury, cadmium, iodine, bromine, hydro molecules, bromine molecules, HO, oxygen, metals. So these are the soft acids, okay. These are the acids having the positive charge, both have the positive charge, but their positivity in the hard acid is high, in soft acid is low. Their relative size of the hard acid is small, the soft acid relative size is a high, larger one. Then is in hard acid their unfilled valence cell, here the filled valence cells are present, so the leading to the high electronegativity, is the other electron seeking, here the leading to the low electronegativity, and there the low polarity, here the high polarity. So here example is given, so you can see the examples where these are the on the right. If you see the periodical tables, these are the example, H plus, lithium, sodium, potassium, or on the right side of the periodic table, and these are the example copper, aluminum, then copper, silver, these are on the left side of the periodic table. So this is in so on the right hand side these are the hard acid, and on the left side that is a soft acids, and in intermediate that is a borderline acid. So these are not, those are not fit in the so hard acid and soft acid is called as a borderline acid. So some Lewis acid which are not example of this few Lewis acid, those are borderline, that is a called as a, that is a ferrous ions, then copper ion, zinc ion, and then PB ion, then tin ion. So these are the different example of the borderline acids. Now hard base, okay. Now hard base, soft base. So hard base is a electron donor having the high electronegativity. It is a electron donor. Hard base and soft base both are the electron donor, but having the high electron negativity. Their negativity, electron negativity is high, then called as a hard base. Easily reducible, can be easily reducible. Stable valence cell structure and having a low polarity, means that they having the stable valence cell structure having the low polarity. These are the called as a hard base. Example you can be carried as a water, OH ion, fluoride ion, acetate ion, phosphate ion, S4 ion. So these are the example of the hard base. Now soft base. Soft base is a electron donor having the high electron negativity. Soft base is a electron donor having the high electron negativity, but easily oxidizable. It is also high electron negativity, but it is easily oxidizable. Empty low lying orbital having the polarity, okay. So you can be say the example of the iodine negative charge having the negative, iodine ions, then cyanide ion, hydronium ions. These are the hard bases. So these are the soft base. So these are called as a soft base. Now borderline base. Which are the borderline base? They are Br minus, SO3 minus. So these are the borderline. So borderline bases also similar way, the those base are not fit into the hard base or soft base, they are the intermediate in the both of the cases. So those are called as a borderline bases. So these are, so this hard base soft concept is given like this. You can be qualitative use, means what is the hard, soft, which can be strong, slow, this like we can be, or quality wise or polarity wise can be concept and be given by this one. Now what is the general concept behind the hard and base concept? We can a general rule is that more stable complex is formed between the hard acid and hard base, and between the soft acid and soft base. Means if you complex stable complex formation between the acid and base, means the hard acid and hard base. If you react with the formation of the stable complex, if react with soft base and soft acid reacting, they form in the stable complex. It is a general rule, means soft with soft, hard with hard. Then second, relative stability of various complex depend upon the relative hardness and softness of acid and base involved. So stability depends, obviously, if a stability of various complex, which are the acids are they involving in the, or which are the base are involving in the formation of the complex. If both are soft, both are depending upon, if both are one of the hard and one of the soft, their stability almost it is less. Like this, the softness would be expected to increase as one goes down any group similarity substrate element in the periodical element. See the here softness, okay, with the see the soft, where the softness are present, where the right side of the this and the hardness of the, and the left side is softness. So when you are to increase and goes down the any group, means if you are from the top to below, you can be on the same group. So hardness on the top side is higher, and you goes down in periodical element on the same column, the softness will be increases. Mean the in the period the higher atoms, higher periodical atom, or we can be called as higher atomic numbers substance having the higher softness, okay, and those atoms or molecules were having the small in size, they have the hardness in there. Then second, similarly the softness decreases. What is the softness decreases from the left to right in any period of the comparative substance element. If you see the periodic tables from left to right, okay, the softness will be decreases. If you start it from the left to right, so you are so comparatively with substance element, you can find the softness will be decreases, means you start from the left to right. Then a proton donor acceptor concept is more easily adaptable to the chemical events, the most of chemical events. But hard, soft, acid base principle is a great value in determining the various aspects of relative acid base strength. Actually, relative acid base strength determining the hard and acid base concept are very popular, and they are understanding the hard base acid concept. Thank you.